Hey students, I wanted to do a couple examples on the definition of the derivative and how to make sure you can handle some really common cases that get a little tricky if you haven't seen them done before. It just takes practice, like everything. So here's our definition of the derivative: that you take the value of the function at x plus h minus the value of the function at x, and you divide it by h, and then you take the limit as h approaches 0 of that. And this whole idea is really just rise over run. We're just subtracting two different y values, and then we're dividing by the run. H is the distance that you moved away. And then that would be a secant line because you're connecting two distinct points. But as you take the limit as h approaches 0, your 2 points come closer and closer together, so you're taking the tangent line. One little nuance that a lot of people forget about is technically you're taking the limit from both sides. So you are considering h being a positive value, so you're moving to the right, and h being a negative value. It's all kind of built into the definition. So if you don't get that nuance, that's okay. So there's really kind of three basic situations that you're going to run into, and when you have to do this, and those are polynomials, rational functions, and then radical expressions. So basically, regular polynomials, but then you've got stuff with fractions, and then you got stuff with roots in it. And the polynomials are the simplest case. So let's just look at an example here of, let's say we've got a function that's like x cubed minus 2x plus 17. And sometimes the binomial theorem is helpful here. Other times, just distributing it out will get you what you need to do. So I'm going to set up the derivative. And we use the f prime to say that I'm taking the derivative. So it's the limit as h approaches 0. And then make sure that you replace each instance of x with x plus h. So this whole chunk that I just wrote right there, this is the f of x plus h. So sometimes it's helpful to put it in parentheses just to like visually distinguish it. You don't need to put that first piece in parentheses, but sometimes it helps to just tell your pieces apart from each other. So then there's f of x. I'm going to divide all of that by h. The nicest thing would be if I could plug in 0 for h, and then I'd have my limit. But I can't plug in 0 for h because that would make the denominator equal 0. So then this is where I was talking about binomial theorem. You've got x plus h cubed. So you can use binomial theorem, or you can just write out Pascal's triangle, or you can just do x plus h times x plus h times x plus h and distribute it all out. However you do it, just make sure that you actually are multiplying x plus h times x plus h times x plus h. So what we end up with is limit as h approaches 0, x cubed plus 3x squared h, x squared h, plus 3x h squared plus h cubed. That's the first piece right there. I just read off the Pascal's triangle coefficients, or you can think of it as 3 choose 1, 3 choose 2, 3 choose 3 with binomial theorem, or you can just FOIL it out. Next, I'll distribute the negative 2. So I have negative 2x, negative 2h. Then I have the 17. Then I'm going to subtract the set of parentheses that was on the right. So we get that. And all of that business is divided by h. I still can't plug in 0 for h. So what I'm hoping is that everything that does not have an h on the top will disappear. So x cubed and negative x cubed, negative 2x and positive 2x, positive 17 and negative 17. And if you did it right, there's a really good check for your work here, checkpoint. Everything remaining on the numerator should have an h in common, and it does. So you can factor it out. If everything on the numerator has an h in common, you can write it as h times 3x squared plus 3x h plus h squared minus 2. And all that is also divided by h. So now the h on top and the h on bottom divides to equal 1, and you're left over with limit as h approaches 0 of 3x squared plus 3xh plus h squared minus 2. And so when you apply h equals 0, you're left over with your derivative function f prime of x is 3x squared minus 2. And what's really nice is, many of you have done derivatives before. You knew by using the power rule that you're going to bring it down and subtract 1. So you're going to bring the power down and subtract 1, and so the constant goes away. You knew the answer was going to be 3x squared minus 2, but you have to still be able to work through it from first principles. So polynomials are all basically the same. You FOIL it out, everything cancels out. The next type of function that I want to look at are rational functions. So let's look at something like x plus 1 over x minus 5. These are a little bit more pain in the butt, but you can do it. Your derivative is going to be g of x plus h. So I go x plus h plus 1 over x plus h minus 5 minus the original function, all divided by h. Sometimes these triple-decker fractions can get annoying, so a lot of times I'll just write times 1 over h to simplify things. Whenever you have two fractions, you always want to think about making a common denominator. So I'm going to take x minus 5 and multiply it on the top and bottom of the fraction on the left. And I'm going to take x plus h minus 5, and multiply it on the top and the bottom of the fraction on the right, so that both denominators match up. And so what I have now is the limit as h approaches 0. Oops, I forgot to write that over here. Just squeeze it in there. Limit as h approaches 0, and then I have x plus h plus 1 times x minus 5 minus x plus 1 times x plus h minus 5 all over x plus h minus 5 times x minus 5 all times 1 over h. I really suggest that you do not worry about distributing out the denominator. That's going to be okay. Don't waste your time on it. Do worry about distributing out the terms on the numerator. So then we get x squared plus hx plus x minus 5x minus 5h minus 5 minus x squared plus hx. Is that a minus 5? Yeah, so then minus 5x plus x plus h minus 5. All that over the same denominator that I'm not going to bother distributing. And I can just put the extra h there from the 1 over h. Okay, now a lot of stuff's going to cancel out. X squared minus x squared. Hx minus hx. Negative 5x minus negative 5x. X minus x. Negative 5 minus negative 5. So assuming I did everything right there was a lot of cancellation. I get limit as h approaches 0 of negative 6h over h times x plus h minus 5 times x minus 5. Just like in the polynomial example, your h's disappear. Now you can plug in h equals 0, and you get negative 6 over x plus 0 minus 5, x minus 5. And those are really the same factor on the denominator twice. So you can write it as negative 6 over x minus 5 squared. That's your derivative. So whenever you have a fraction, a rational function, you want to find the common denominator and cancel everything out when you're doing first principles. And the last type I wanted to do is just a radical function. So let's say I have the square root of 3x plus 7. Then my derivative is going to be, it's the same process. Limit as h approaches 0 of the function with x plus h minus the function itself, all divided by h. Now there's this idea that I'm going to use here, and the idea is that if I have the difference of two squares, that's a minus b times a plus b. So what I'm going to do is, because I would like to get rid of my square roots, I wish my square roots would go away. So I'm going to multiply by almost the same thing that I started with. The only difference is that I switched it to be an a plus b. So what I've done is I have here a minus b, and I have here a plus b. I can't multiply just one part of a fraction that changes the value. So I also need to multiply the denominator by the same exact expression, because then I've multiplied by a nasty version of the number 1. So if you distribute this out, the square roots cancel. This gives me a positive AB. This gives me a negative AB, which cancels out. And then the square roots cancel out. So you end up with r prime of x equals the limit as h approaches 0. You now have 3 times x plus h plus 7 minus 3x plus 7 on the numerator. And on the denominator, you have all this nasty stuff. If you distribute out on the numerator, you get a lot of the same stuff. 3x plus 3h plus 7 minus 3x minus 7. And on the denominator, I'm just going to save myself some writing and say this piece just goes right there. The numerator, we have 3x and negative 3x. We have positive 7 and negative 7. So all that's really remaining is to do the limit as h approaches 0. And we have 3h over h times 3x plus h plus 7 plus root 3x plus 7. I can cancel out the h's and plug in 0 for h. So now I have 3 over 3 times x plus 0, so just 3x, plus another copy of root 3x plus 7, which means I have 2 copies of root 3x plus 7. So those are really the most common situations you'll see when you're deriving from first principles. If you have other questions, like about a different function, anything like harder that you'd like to see me derive from first principles, most of them you can do if you have a sufficient number of a sufficient amount of patience and just brute force algebra skills. But just let me know if you are like, what about the 5th root, or what about the absolute value? And I'm happy to do that for you. So thanks. Comment if there's anything confusing, or let me know what other videos I can make to help.